Good afternoon, everyone, and welcome. So we're going to talk about offshore deepwater plays today in the next coming hour. Let me use the slide that you can see on both sides of the stage to introduce you to the subject. Since 2020, around 77 billion barrels of oil equivalent recoverable have been found in Africa. And very interestingly, 86% of this volume was found offshore. On the map that we're displaying here, you can see the top 68 discoveries, which hold at least 200 million barrels of oil recoverable. But interestingly, if you start breaking down those 86% according to the water depths in which those resources were discovered, you see that 9 billion barrels of oil equivalent were found in a water depths ranging from the surface basically to 1,000 meters water depth. 38 billion barrels of oil equivalent were found between 1,000 and 2,000 meters of water depth. And finally, the remaining 20 billion barrels of oil equivalent were found down to 3,000 meters of water depth. So obviously, going offshore, deep offshore, is certainly the way to success. But on the other hand, you have to realize that it's going to be challenging from a technical point of view to bring that hydrocarbon onto the ground, onto the surface. And it's going to be capital intensive. So that's the general framework in which I would like to have a conversation with my panelists today. So I welcome them and I thank you them for being here. I'm going to start with you, Peter, because you're representing the explorer on this panel, even though if you're not an operating company, but you have more than a successful track in exploration, in seismic. So I'm going to start with you, asking you your opinion on seismic acquisition. Peter, so has any recent innovation improved the identification of deep water prospects or play? Shall we start from OBN technologies and move forward? Sorry.
Very good. Thanks, Cyril, and good afternoon, everyone. First of all, it's an absolute pleasure to be part of this conversation, and a conversation which is very timely, I think, for the African continent and the huge potential there still is across the continent. So coming back to your question, I would like to start a little bit wider and really express the importance of seismic data in general. I think that's at TGS, we believe the high quality data is absolutely the foundation to a successful exploration effort. And I think that's an important point to start with. It's the first and probably the most critical part in order to identify the prospects, but also de-risk prospects. And it's the foundation of your future financial commitments and guidance on further investments as well. So I think that's an important point to start off with. Now, from a seismic technology point of view, I think this has evolved throughout the last few decades from 2D to 3D, from time to depth migrations and so on, but also coming towards the OBN side, from single to multi-sensor streamer seismic to ocean bottom nodes. And clearly, the ocean bottom node technology has proven to be quite a critical component in identifying or into optimizing the subsurface image, especially in those areas where it's extremely complex. And that's what we're dealing with often in these deepwater environments. So that's where it's been a critical tool to create a more accurate image, but also reducing the risk. And that's the risk we're going to talk about a lot more with all the other panelists as well. Is OBN the last step? Certainly not. I think it's a milestone, not a destination. And I think the real innovation is how we combine the OBN technology with the other technologies around. Think about how we use the sources. Low frequency sources, for example, are a critical component in that, but also the way we process the data, how we make use of the latest and greatest cloud compute technologies, full waveform inversions, and so on to optimize that data. So I think that's a critical component. So in all of this, I think the key messages as well is the flexibility in being able to use a variety of tools is going to be critical.
Okay, thank you. Thanks very much. I'm going to hand over to you, Jean-Charles, asking you pretty much the same question. You're an expert in hydrocarbon production, especially oil, with an amazing track record in the building and, well, in the designing and building FPSOs. So I also would like to hear from you about the latest innovation. Has any innovation recently enabled to be more efficient in the recovery of deep water reserves? Can you elaborate on that?
Thanks for the question. Thanks for the invite. Very happy to be here. I'll quote you what you just said. You said deep offshore is the place to succeed.
Yeah.
I like that very much. I think this is music to our ears. And I think here we talk about de-risking. I think, Peter, you just mentioned it. If you want to de-risk these complex developments from the surface perspective, the first thing is you need to deliver. It's as simple as that. So we need to build on our expertise. We need to be able to deliver a safe, reliable, predictable, and cost-effective solution. Yeah. And maybe a couple of ways we can look at it. We can look at the standardization and modular approach to FPSOs. Mm-hmm. If you want to have a solution that is predictable, you need to build on your own knowledge. So at SBM, we've been for decades, building on this knowledge, creating our own referential and standard, and this is what we deploy to deep offshore solutions. So that's a great way to de-risk. Yeah. And we've installed FPSOs in close to 3,000 meters of waters in the past, so why not learn from that to continue? Yeah. It doesn't sound very high-tech, but this is very efficient. Okay. I think another one, if you think about the remoteness of this environment, yeah, will be the use of AI and the use of remote monitoring. So we're installing on our asset facilities to operate and monitor the asset from shore. So with that, you de-risk anything that has to do with the remoteness of the asset. So that's a great way to reduce exposure of people, but also to increase efficiency. And that comes with dollar per barrel economies. And I would say maybe another point we can discuss, and this, what makes or breaks this deepwater plays is how you maintain those assets. So there's one thing to build them, but when we have to operate and maintain for the next 20, 25 years of life of these assets, you want to make sure that you do it the most efficient and safe way possible. So it's down to robotics, yeah, remote inspections, how much can we do from shore, how much can we prepare onshore. And there, I think it's also a very, very powerful way to enable the local population in the countries we operate, because you need to build those capacities in country. I think I invite those of you in the room that have not, if you look at the Total Energies booth, they have a drone there for emission mapping, and this is the way to go for offshore deepwater plays.
So if I'm correct, understanding correctly, there's a constant addition of new innovation that's bringing to move forward. So this takes me to the next question to you, Chijioke. So following Jean-Charles' remark, so new technologies is constantly being implemented. However, we are hearing sometimes operators claiming that costs are constantly increasing. Do you see an opportunity to mitigate those cost increase, or is it simply the fact that the ability of recovering more just justifies, simply a cost increase?
So there is a correlation between the recovery you're able to make with the expenditure that you have to incur with technology, with equipment and all that. So you have to be able to balance the recoverable, see the tangible recoverable against what's going to cost you to do that. But what is key is that technology continues to improve, like you were saying earlier on, Jean-Charles. Technology continues to improve and continues to give us an opportunity to make recovery at those very ultra-deep water locations optimal.
Okay, thanks very much. I have a last question to you, Peter, before I move to Samuel, because I want to hear Samuel I want to hear the perspective from the operators. But Peter, just one question concerning AI. You know, AI is being rolled out in many sectors, including oil and gas exploration and production. So I would like, could you briefly outline, I mean, what are the advantages what AI has brought to seismic interpretation, and how AI is de-risking the identification of potential plays?
Yeah, it's an excellent question, and probably not I can answer in 34 minutes even. So
Okay.
let alone that.
So but
it's an excellent question. Of course, seismic interpretation in particular is the foundation to understanding the subsurface, and that's what it's initially is all about. But the time frames to get to that are long, and a lot of the data we deal with often is very complex. And I think this is where the AI machine learning comes into play. Not only on the interpretation side, Jean-Charles already mentioned automation and remote operations. We've generated automated maintenance schedules, for example, based on machine learning, understanding when to replace a certain piece of equipment, for example, and not on a standard schedule, but something which is a bit more intelligent. Just an example. The satellite, low orbit satellite, now enables us to stream data directly from our vessels, and this is an acceleration of data transfers, which is something we've not seen in the past. But it also helps with the quality of the seismic data, okay. and that's where it starts to become very important in de-risking again what we're looking at, how we're interpreting things. Very simple things as noise reduction. We can have machine learning algorithms to detect the noise, remove the noise, and give us a better idea what is out there. Ultimately, de-risking that last bit when the wells are going down, that we're making sure it's in the right place. So.
And you're using successful examples.
Yeah, exactly. So when it comes to noise reduction and so on, that's happening all the time. But we also have algorithms, for example, searching for these very low amplitude diffraction tails. And if you can map them, you can get an accurate idea of some faults, for example, in the subsurface which you've not seen before. And that's where it starts to make a massive difference, not seen before. So it starts to have an impact on the risk, not only for an oil and gas or a hydrocarbon exploration, but also for applications like carbon capture and storage. So I think that's where it really helps. At this stage, I don't think AI is simply replacing geoscientists just yet. I think it's definitely a strategic partner at this stage, and something which speeds up things, and time is of the essence.
Thanks very much. So I'm going to try to bring the conversation to operation challengers level, and I'm going to hand over to you, Samuel. From an operator's perspective, you know that gas discoveries in carbonate reservoir often represent a more challenging situation. Mm-hmm. I'm thinking, for example, about Zohr in the East Mediterranean Sea, where the operators has found some gas in a carbonate reef structure, which is clearly challenging to produce from. Would you say that, do you prioritize clastic objectives over carbonates objectives, especially in deep offshore environments?
Thank you, Cyril. Good evening, everyone. Thank you for having me to discuss the future of exploration and production in deep water. Yes, indeed, gas discoveries in in carbonate reservoir like Zohr has demonstrated both the potential and the complexity of this kind of reservoirs. Carbonate reservoir usually present challenges like heterogeneity, porosity, permeability, variable porosity, permeability distribution, challenges with water management during production. All these complicate our ability to model carbonate reservoir and forecast production. While baleine success, baleine discovery is encouraging, it doesn't eliminate, if I take baleine example in Côte d'Ivoire, while it's a success, it doesn't eliminate the geological and the operational risk inherent to this kind of reservoir. Therefore, in a deep water context, it would be prudent to have a balanced portfolio.
Yeah.
Yeah. So coming to the clastics, especially with turbidite system, they are more predictable in terms of reservoir quality and continuity. That translates to more manageable
risks
development and production strategies. So in classic system, we don't need to, when we have a portfolio, we don't need just to focus on carbonate or clastic, but we, as I said, we need to have a balanced portfolio. So focusing on classic prospect, in fact, would help to mitigate the risk associated with deep water, and for sure help to improve the overall economics of our portfolio.
Okay, thanks very much. Thank you. Shijoke, I'm turning to you. I'd like to address the question of bottlenecks in the development of discoveries. So you probably have in mind some stranded assets in the Gulf of Guinea, in the Nigerian waters. I'm also thinking about the Namibian discoveries, which will certainly come on stream at some point. But do you foresee any bottlenecks if those resources had to be developed more or less at the same time? Is it something that we should be taking into consideration, or isn't it the case?
Well, the bottlenecks will definitely make themselves felt, so to speak. So there will be between the operators, the infrastructure service providers, and the government agencies that regulate the operating conditions, you'd have to find some harmony, okay, that would make it possible for either pooling resources or finding ways of collaborating even between the operator and the service provider that has come to install the infrastructure for him, yes.
Okay, thanks very much. Let's bring the conversation to into environmental challenges and emission, because we all know that emission is a very hot topic at the moment. And I want to stay with you, Chijioke. We often hear that African hydrocarbon production is frequently, people frequently points finger at African production, saying that scope 1 and 2 emissions are not properly abated, and particularly in terms of flaring. So do you think technology can play a role in reducing those emissions while maintaining costs at a competitive level compared to other places around the world? I know Jean-Charles has got a part of the answers, but I want to hear from you first.
So that finger pointing is, this is my opinion. Yeah. That finger pointing is more politically driven than technical. But having said that, the fact remains that a lot of gas in the African continent is flared, and the technology exists already to harness that gas and put it to good use. If you take Nigeria, for example, we have woken up to the fact that our gas asset is our gold. Yeah. And it is about time we pay more attention to harnessing that for domestic use, for export. So we are well on the track of utilizing the gas to the benefit, not just for security and environmental compliance, but also because it has a potential to generate a lot of revenue for us. Yeah.
Thank you. So Jean-Charles, I'm turning to you. So regarding flaring, so have technological advancement progressed in that area? Are we able to say that gas separation and compression can be processed as quick as flaring?
So,
do you have a solution for that?
No, thank you. So decarbonization at large, I think this is one of our strategic priorities as a company, but I think as an industry in general. And then mentioning that Africa is not at the forefront, I think is slightly off topic, because there's been amazing development offshore West Africa with really breakthrough technologies for carbon reduction. So I think that statement might be somehow outdated and needs revisiting. What we're seeing today, we have a vast portfolio of technology we could apply. We're looking at closed flare systems. We're looking at deep suction hose to get colder water from the ocean and in turn, have less power demand on our asset, therefore less emissions to the atmosphere. We can rediscuss again about AI, and now the improved efficiency has actually reduced the CO2 per barrel emission equivalent. And if you think specifically for deep water fields, they're usually very large, production intensive units. So actually, the performance in terms of emission per barrel is very good. I think at SBM we are 45% below industry average in terms of emission, and this is with great pride that we can say those numbers, and we want to continue along those lines. So I think you mentioned carbon capture and storage. I mean, this is something that can be another breakthrough to the industry. I mean, we've partnered up with MHI, Mitsubishi Heavy Industries, and we're designing modular solutions for FPSOs. I mean, when those can be, made available to the market to, reasonable competitive pricing, they'll surely achieve, significant reductions.
Okay, so the solutions exist
or are being developed. I think earlier this year we got an approval in principle by ABS for a near zero FPSO, and that near zero FPSO can cut emissions, if you look at standards today, by 80%. Okay. Those solutions exist or are in the process of being made available to the market.
Thanks very much. Okay, Samuel, I'm turning over to you, and I would like to hear from you from an operator perspective. How do you balance the economic viability of deep water production and with the increasing pressure of decarbonizing and taking into account this energy transition being the trend now?
Yeah, thank you, Cyril. So as we push into deep water, the challenge is not technical and economic, but also increasing pressure to operate sustainability and responsibly. Our goal is to deliver sound economically project while contributing to the global transition goals. We have the baleine feed that stands as a very nice example of how we can how profitability and sustainability can align. For the baleine project, from day one, we integrated in our process reduction of carbon emission. We integrated gas valorization, so the gas is used for domestic power. For domestic, we use it for power generation. We've been able to have system to minimize flaring. We flare when we have some issues with our compressors, but is now stabilized, so we don't flare. And we have some digital tools that help to monitor and optimize our carbon footprint.
And at PetroC, would you say that this is becoming now the new norm? Is it for your next project?
Yes, of course. We've learned a lot from the baleine project.
Yeah.
So with our other operators like CNR, Foxtrot, even Murphy. Murphy is in the exploration stage, but in all the process, we have this carbon emission reduction thinking in all the process we have.
Okay, thanks very much. Jean-Charles, I want to turn over to you and ask you about, to start speaking about future outlook and industry trends. I would like to know if there's a technological revolution on the horizon that could transform deep offshore production. Do you have something, do you see something happening, maybe except AI or a side of AI?
No, so indeed, it's a difficult exercise looking forward, because most of the time you will look stupid in the future, but I'll give it a try. So AI indeed is one of the building blocks, but I think Peter, you mentioned it. It's not a standalone. It's not going to do everything and replace everything standalone. Yeah. It has to come with other building blocks and other experience that we can bring to AI. So AI certainly has a place. We don't believe this is going to be the sort of magical solution, but one of the trends we're seeing is more towards implementation of gas monetization offshore on assets. We can talk about hydrogen. We can talk about ammonia. So how do we manage associated gas? How can we sort of process it further to monetize it on the asset? So making better use of the capital that's already employed and the real estate that's already floating on the surface above the field to keep monetizing the asset. So I think that is one of the important elements we see that can play a very big role in the future.
Okay. And are you thinking ahead of your customers' needs, or is it something that you're implementing because of your because your customers are requesting it for it?
So I think we're very close to our market, to our customers, so we understand a little bit the dynamics that the industry is facing. We also collaboratively develop new solutions to respond to the demand. So we cannot create a product that everybody will adopt. We have to co-create it. So it's a bit of an exercise where you need to break barriers between contractor and company, and we need to together get to the table and say, okay, this is what we can do. That's the limit. Does it work for you? No, it doesn't. We readapt it. We do it iteratively. And then talking about ammonia, this is how it started. It starts with understanding our client needs. And then, of course, we try to be proactive to design, conceptually this type of product. Also there we get approvals in principles with class society to make sure that we can deliver this to the right standards to the market. So we try and be ahead of our client, but together with our clients.
Okay, thank you. Chijioke, based on what Jean-Charles said, I mean, do you perceive a correlation between increasing water depths and increase of costs in the development of oil assets?
Well, there's no doubt that water depth is a critical factor in the cost increase, but it's not a solitary factor. There are lots of other factors that affect the geography or rather the topography of the field, the geology of the field has a role to play in how expensive it is to drill. Then the temperatures and pressures that you have to deal with at that depth are also factors that managing all that process is. But then there are also mitigating factors. If you're operating at that depth and you have equipment that are modularized or standardized, it makes it. All these are factors that help to contain the cost.
Okay, so there's no way to decouple costs versus water depths.
No, there is no way to decouple it, and the fact is that as much as there are factors that drive cost, there are factors that mitigate the costs as well. So,
thanks very much. Peter, on your side, do you see any revolution on the horizon coming in on the seismic front?
I guess I'm looking into the same crystal ball as the others, but I would more call it a continuous technology evolution rather than a revolution in the way I see it. But when it comes to deep water exploration, it's clear that certainly historically that's the domain of the super majors. So high cost, complex risk profiles are not everyone's. Are not for everyone, I think. So. But when it comes to technology, and certainly from my point of view, that should not be necessarily the blocking factor here. I think with all the tools and a little bit of the AI story we talked about, we have a lot of good quality data available. And at TGS, we have around 70% of the multi-client data in the region easily accessible, and this is. Revitalized, rejuvenated on a very regular basis to keep it fresh and keep it as high quality as possible. Okay. And I think that's an important part. So would that encourage medium-sized explorers? I think certainly from a technology point of view, I would say so. Yes. Absolutely. I think that technology is really leveling the playing field. Yep. Clearly, the technology is not the only component. There are other aspects, fiscal regimes, regulatory processes, and environmental aspects, as we discussed. But I think from a technology point of view, I think we can clearly say there is opportunities for these medium-sized companies to play a significant part going forward.
And by revisiting, refining, I mean, the seismic treatment or acquisition that you've made by de-risking, in fact, the opportunity of finding new prospects. Do you believe that this would maybe attract, I would say, let's say, mid-sized players, for example, to start exploring? No. Look for deeper assets.
Exactly, and I think the better the tools, the better the technology, and with the cloud computing, the AI we talked about, the quality and the amount of confidence you can put into that subsurface image is ever increasing, and with that, the risk, it's never going away, but it's definitely being significantly reduced going to that next step. So with that, it should be more attractive to more people.
No, great, thanks. Samuel, as the only operator on this panel, I wanted to ask you, what lessons have you learned from your previous experience in terms of exploration or even, in the past projects that are now influencing your approach for new frontiers opportunities? Do you have a concrete example where maybe you may have done things, you could have done things in a better way, and that you would do differently today?
Yes, Petrosi, we are operator, but we operate a shallow marine, two shallow marine assets. But we have quite good experience in deep water, since we are a partner as a national oil company. We are partner in all of the operated blocks. So we've learned a lot, as I mentioned earlier, that through the Baleine project, we know that we need to make early investment in seismic. For example, the country with the ministry, Petrosi and the ministry, we've been able to have contract with all the seismic service provider like TGS, Viridian, and Avex. So we have a multi-client project contract, and they are asked to reprocess all the legacy data using the latest technology. So we have waveform inversion, all those latest technology. So we have good imaging, so the companies can use them for the exploration study. And on the operation side, with drilling, with E&I, we know how to manage high pressure, high temperature drilling. And on the FPSO side, we have, with Baleine, we have an FPSO equipped with latest technology, even AI technology, to help us to monitor and reduce our carbon footprint. So in general, we are well placed to advise all the new IOCs that wants to come and operate in the country.
So working with the right data, the clean data, is definitely the key to success.
Exactly. The right data, and using AI, because AI is very important now, as he mentioned, to reduce noise and to have a very good imaging of the subsurface.
Okay, thanks very much. We are getting close to the end of this conversation. We might have time for one question from the audience, if someone wants to jump in. Otherwise, I'm going to warmly thank my speakers for coming today and sharing their view and knowledge on deepwater plays. So I think we can give a round of applause. Thanks very much. Thank you.
Thank you.